Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from Google prototype to production, the Agent Ops lifecycle. You can spin up an impressive AI agent demo in minutes, but turning that demo into something your business can safely depend on is a very different challenge. In practice, most of the work isn't in the model or the prompt, it's in the infrastructure, security, and validation wrapped around it. And because agents are autonomous, interactive, and stateful, they introduce risks that traditional ML and DevOps practices don't fully cover. This white paper lays out Agent Ops, a practical, end-to-end discipline for getting agents from prototype to production and keeping them trustworthy once they're there. When teams skip the last mile work, the failures are rarely subtle. A customer service agent might be tricked into giving away products because guardrails were never enforced. A misconfigured authentication layer can expose confidential databases through a chat interface. Without monitoring, an agent can quietly rack up a huge bill over a weekend. And if you don't continuously evaluate behavior, an agent that worked yesterday can degrade without anyone noticing. These aren't just bugs, they're business failures. Agent Ops is about preventing exactly these kinds of incidents. Agents don't behave like fixed microservices. They choose tools on the fly, so every request can follow a different execution path. That means you need versioning, access control, and observability not just for code, but for tools and prompts as well. They also maintain state and memory across sessions, which raises complex questions about how to store, secure, and scale that information. And because their trajectories vary, both cost and latency can swing wildly unless you actively manage them. To handle all this, you need three pillars in place: automated evaluation, automated deployment through CI/CD, and comprehensive observability. It's tempting to think of Agent Ops as purely a tooling problem, but the most reliable systems are built by well-coordinated teams, not just clever pipelines. Cloud platform teams own infrastructure, security, and access control. Data engineers manage the pipelines and data quality. Data scientists and MLOps engineers build and automate the ML lifecycle. Governance teams ensure compliance and accountability. Generative AI adds new roles like prompt engineers and AI engineers who design prompts, guardrails, and scalable backends. In small orgs, one person may wear several hats. In larger ones, these are distinct teams. Either way, Agent Ops only works when these people and processes are aligned. In a mature Agent Ops setup, responsibilities are clearly split. Cloud platform teams provision and secure the cloud environment, enforcing least privilege access. Data engineering teams build and maintain the data pipelines that agents rely on. Data scientists and MLOps engineers experiment with models and automate training and deployment pipelines. Governance teams track metrics, artifacts, and approvals for compliance. Prompt engineers and AI engineers design prompts, integrate tools and retrieval, and embed evaluation and guardrails into the system. Finally, DevOps and application developers build the user interfaces and services that connect users to the agent backend. Clear ownership across these roles is what turns a promising prototype into a dependable product. Once the team is in place, the key question is, how do we turn their work into a system users can trust? The central idea is evaluation-gated deployment. No new agent version should reach users unless it has passed a comprehensive evaluation that proves its quality and safety. Pre-production is where you replace ad hoc manual checks with automated repeatable gates. That phase rests on three pillars: a rigorous evaluation process, an automated CI/CD pipeline that enforces it, and safe rollout strategies that reduce risk when you finally flip traffic to the new version. Traditional tests check whether functions behave as expected, but agents can pass every unit test and still fail badly by choosing the wrong tool or hallucinating a confident answer. That's why you need behavioral evaluation that looks at the entire trajectory: the reasoning steps, tool calls, and final response. Teams usually start with a manual, pre-pull request process, where engineers run an evaluation suite locally and attach the report to the PR. As they mature, they move to fully automated in-pipeline evaluation, where a failing score automatically blocks deployment. In both cases, you rely on a curated golden dataset and metrics like tool call success rate or helpfulness, often powered by LLM as a judge or services like Vertex AI evaluation. Agents aren't just code, they're prompts, tool definitions, configuration files, and model choices. A small change in one of these can have big behavioral effects. A well-designed CI/CD pipeline acts like a funnel, catching problems as early and cheaply as possible. In Phase 1, pre-merge CI runs fast checks and agent evaluations on every pull request. In Phase 2, successful changes are deployed to a staging environment that mirrors production, where you run heavier integration and load tests and let internal users dogfood the system. In Phase 3, a human-approved gated deployment promotes the exact tested artifact into production. This structure gives you confidence at each step without slowing teams to a crawl. To make this three-phase pipeline reliable, you need strong automation. Infrastructure as code tools like Terraform define your environments in version-controlled templates, so staging and production stay in sync. Automated testing frameworks like PyTest run unit tests, security scans, and agent evaluations, including checks on conversation histories and tool traces. Sensitive data like API keys should never live in your repo. Instead, use a secret manager and inject them at runtime. Google's Agent Starter Pack ties these ideas together with ready-made CI/CD configs, Terraform, evaluation hooks, and observability, so you can see a full implementation rather than starting from scratch. Even with strong pre-production checks, real users will always surprise you. Instead of sending all traffic to a new agent version at once, use safe rollout patterns. Canary releases start with a tiny slice of users and scale up only if metrics look healthy. Blue-green deployments run two production environments side by side, so you can switch traffic instantly and roll back just as fast. A/B tests compare versions on real business metrics, and feature flags let you turn capabilities on and off without redeploying. Underneath all of this is rigorous versioning, not just for code, but for prompts, tools, models, memory schemas, and evaluation datasets. With GitOps, your repository becomes the single source of truth, and rollback is as simple as reverting a commit. A perfectly deployed agent can still be unsafe if its behavior isn't governed. Because agents interpret ambiguous requests, call tools, and maintain memory, they're vulnerable to prompt injection, data leakage, and memory poisoning. Security has to be baked in from day one, not bolted on later. Google's Secure AI Agents approach and the Secure AI framework outline a layered defense. Start with clear policies and system instructions that define what the agent should and should not do. Add enforcement layers like input and output filters, safety classifiers, and human-in-the-loop escalation for high-risk actions. Then continuously test and read-team the system, updating your evaluation datasets and guardrails as new attack patterns emerge. Think of system instructions as the agent's constitution. They encode your policies and constraints into the core behavior. Around that, you build guardrails. Input filters inspect user prompts for toxicity, prompt injection attempts, or policy violations before they ever reach the model. Output filters, such as Vertex AI's safety filters, scan responses for harmful content, PII, or other restricted information before sending them back to users. For ambiguous or high-impact actions, the system should escalate to a human reviewer. And whenever you change the model, prompts, or safety settings, you rerun a full safety evaluation suite so you don't accidentally reopen old vulnerabilities. Once your agent is live, the challenge shifts from getting it out the door to keeping it reliable, affordable, and safe at scale. Unlike a traditional service with fixed logic, an agent can follow unexpected reasoning paths and accumulate cost or risk in ways you didn't anticipate. To manage this, you adopt a continuous loop. First, you observe, collect detailed logs, traces, and metrics to understand what the agent is actually doing. Then you act. Use operational levers to adjust performance, cost, and safety in real time. Finally, you evolve. Turn production insights into durable improvements to prompts, tools, and architecture. This observe-backed evolve cycle is the core of agent ops in production. To trust an autonomous agent, you need to see how it thinks and acts. Logs give you the raw facts, which tools were called, what inputs and outputs were used, and where errors occurred. Traces stitch those events into a narrative, so you can follow a single user request across model calls, tools, and services using a shared trace ID. Metrics roll everything up into dashboards that show latency, error rates, cost per request, and other key indicators. On Google Cloud, this is supported by CloudTrace, logging, and monitoring, with the Agent Development Kit providing built-in instrumentation. With these three pillars in place, you move from flying blind to having a clear, data-driven view of your agent's behavior. Observability only pays off if you can act on what you see. For performance and scale, the first step is to decouple the agent's logic from its state. Run the agent as a stateless containerized service on platforms like Cloud Run or Vertex AI Agent Engine. and store session state and memory externally. For long-running tasks, use event-driven asynchronous patterns so the agent stays responsive while background work continues. Architect for resilience with retries and idempotent tools so transient failures don't cause double charges or inconsistent state. And constantly balance three competing goals. Keep latency low, reliability high, and costs under control by choosing appropriate models, caching aggressively, and batching where possible. Because agents can take actions on their own, you need a clear playbook for when something goes wrong. The sequence is contain, triage, and resolve. Containment is immediate. Use a circuit breaker or feature flag to disable the risky tool or capability and stop the damage. Next, triage by routing suspicious interactions into a human review queue to understand what happened and how far it spread. Finally, resolve the root cause by updating prompts, filters, or policies, and push that fix through your standard CI/CD pipeline. That way, even your security patches are tested and evaluated before they go back into production. The evolve phase is where you turn operational pain into long-term gain. Start by analyzing production logs and metrics to spot patterns. Tasks with high failure rates, confusing user flows, or recurring safety incidents. Then convert those failures into new entries in your evaluation dataset, so they become regression tests for future changes. Based on those insights, refine prompts, add or improve tools, or tighten guardrails. Commit the changes, let the CI/CD pipeline run tests and evaluations, and roll out safely using your chosen deployment strategy. The faster you can run this loop, the faster your agent improves. Security isn't a one-time checklist. It's a continuous arms race. In production, you'll see real users and adversaries trying things you never anticipated. When your monitoring surfaces a new prompt injection or a subtle data leak, treat it as a learning opportunity. Capture the attack as a new test case in your evaluation suite. Update system prompts, input filters, or tool policies to block that vector. Then run the full CI/CD and evaluation pipeline before redeploying. Over time, this observe, act, evolve loop turns every incident into a permanent strengthening of your defenses. As organizations mature, they rarely have just one agent. They might have a customer support agent, a forecasting agent, a fraud detection agent, and more, often built by different teams, using different frameworks, and even running in different clouds. Without a common way to connect them, each agent becomes an island. Teams rebuild the same capabilities, and valuable insights stay trapped in silos. To unlock the full potential of agentic systems, you need interoperability standards that let agents discover and safely delegate work to each other, regardless of how or where they were built. Two complementary protocols help solve interoperability at different levels. The Model Context Protocol, or MCP, standardizes how agents talk to tools and resources, things like calculators, databases, or APIs with well-defined inputs and outputs. The Agent-to-Agent Protocol, or A2A, focuses on collaboration between full agents that can reason, plan, and maintain state. If you want to say, call this function with these parameters, you use MCP. If you want to say, analyze last quarter's churn and propose 3 interventions, you use A2A to delegate that goal to another intelligent agent. Mature systems use both, A2A for high-level coordination, MCP for low-level tool use. A2A starts with discovery. How does one agent find another that can help? That's where agent cards come in. An agent card is a standardized JSON document that acts like a business card for an agent. It describes the agent's capabilities, skills, security requirements, and how to reach it over the network. With agent cards, any agent in your ecosystem can dynamically discover and connect to others, even across teams or clouds. Frameworks like Google's Agent Development Kit can generate these cards automatically and expose them via a simple endpoint, making it easy to retrofit existing agents for A2A compatibility. Once an agent is A2A enabled, other agents can treat it as a powerful collaborator. With the ADK, you can wrap an existing agent in a small A2A adapter, which generates its agent card and serves it over HTTP. Other agents can then load that card and call the remote agent as a sub-agent, just like they would a local component. This makes it easy to build hierarchical systems, where a root agent orchestrates both local helpers and remote specialists. To make this work in production, you need distributed tracing so every cross-agent request carries a trace ID, and solid state management to track progress and maintain consistency across these interactions. A2A and MCP aren't competing, They're layered. Imagine an auto repair shop run by AI. A customer describes a problem to a shop manager agent over A2A. The manager reasons about the issue and delegates to a mechanic agent, again via A2A. The mechanic then uses MCP to call specific tools, a diagnostic scanner, a repair manual database, a lift controller. Later, the mechanic might use A2A again to talk to a parts supplier agent. In this setup, A2A handles the high-level, goal-oriented conversations between agents and users, while MCP provides the plumbing for precise, structured tool calls inside each agent. Not every organization needs a registry on day one. With a few dozen tools or agents, you can manage configuration manually. But once you reach thousands of tools or many specialized agents across teams, discovery and governance become real problems. A tool registry built on MCP catalogs all available tools and lets you create curated subsets for generalist, specialist, or dynamic agents. An agent registry built on formats like agent cards does the same for agents, helping teams find and reuse existing capabilities. Registries improve discovery, security auditing, and reuse, but they add maintenance overhead, so it's wise to introduce them when scale truly demands it. Putting it all together, the agent ops lifecycle starts with the developer's inner loop, rapid local experiments to shape the agent's core behavior. Once a change looks promising, it enters the pre-production engine, where automated evaluation gates and CI/CD pipelines validate quality and safety. Safe rollout strategies then introduce it to real users. In production, a continuous observe, act, evolve loop turns logs and metrics into operational actions and long-term improvements. As your ecosystem grows, interoperability protocols like MCP and A2A let agents share tools and collaborate, so you're building not just isolated point solutions, but a coherent, intelligent network. The hardest part of deploying agents isn't getting a model to respond, it's everything that happens around it. Most projects stumble in the last mile because they underestimate the operational complexity of autonomous systems. Agent Ops reframes this as an organizational discipline that spans people, process, and technology. The immediate payoff is fewer incidents and faster recovery when things go wrong. The deeper value is velocity, the ability to ship improvements in hours instead of weeks, and to evolve your agents continuously. If you're just starting, focus on the basics. Build your first evaluation dataset, wire it into a CI/CD pipeline, and set up robust monitoring. From there, you can layer on interoperability and multi-agent collaboration as your ecosystem grows.